The steady state error when the input is ramp signal, unit ramp signal. So we know that the steady state error formula, limit s tends to 0, s into r of s by 1 plus g of s into h of s, and input is ramp signal, unit ramp signal. So therefore input is unit ramp signal, that's why r of s is equal to 1 by s square. So from this steady state error constant, ESS can be written as limit s tends to 0, s into 1 by s square divided by 1 plus g of s into h of s. This s and this s will be gets cancelled out, and here ESS can be written as limit s tends to 0, 1 by s into 1 plus g of s into h of s. This can be further extended like limit s tends to 0, 1 by s plus s into g of s into h of s. So if we apply limits to this denominator function, this function will become 0. So therefore directly ESS can be written as 1 by limit s tends to 0, s into g of s into h of s. So this is nothing but velocity error constant. So therefore the steady state error constant for unit ramp signal is 1 by kV, where kV is the velocity error constant. So here let us check for type 0 system. Type 0 system, then kV is the velocity error constant for type 0 system is limit s tends to 0, s into g of s into h of s. So where it can be written as limit s tends to 0, s into, so this k into s plus z1, z2 zeros, all these are zeros, so on, divided by s plus p1, s plus p2 and s plus p3, so on. So when you apply the limits to this s power of 0, so everything will become 0 here, and the velocity error constant kV becomes 0. So steady state error constant for type 0 system is 1 by kV, which is nothing but infinity, So the conclusion here, hence in type 0 systems, when the input is unit ramp signal, the steady state error is infinity. So if you take for type 1 system, kV is equal to limit, same formula I am giving, s tends to 0, s into g of s into h of s. So here for type 1 system I have to take s into k into s plus z1 into s plus z2 into s plus z3, so on, divided by type 1 system. So it is s into s plus p1 into s plus p2 into s plus p3, so on. So here this and this s will be gets cancelled out. Now this one will become a constant. So here for type 1 system, kV becomes constant and steady state error is nothing but 1 by kV, which is a constant. So for type 1 systems, the system with the unit ramp signal will be constant, the steady state error will be constant. So we'll see for type 2 system. So same formula I am just taking, limit s tends to 0, this is kV, s tends to 0, s into g of s into h of s. So for type 2 system I have to take s square in the denominator. So here this is s plus z1, s plus z2 into s plus z3, so on, divided by s square into s plus p1 into s plus p2 into s plus p3, so on. So this s and 1s will be cancelled out, and this kV will become, for type 2 system, this will become infinity, and the steady state error will become now 1 by kV, which is equal to 1 by infinity, which is nothing but 0. So this is the conclusion, that for the systems having type number 2 and above, for unit ramp signal, the steady state error constant will become 0, and the velocity error constant will become infinity.